proportions. A proportion is a set of two ratios. We often write the ratios as fractions when solving proportions. So we could write our ratio as 2 to 3, and then this would be the same as 6 to a number, which we can learn how to solve, or we can write it as a fraction. So 2 over 3 is equal to 6 over a number, again, that we could solve. And I'm going to show you how to solve for those missing values. But most of the time when you're solving a proportion, you'll see this written as a letter. So for example, like an X. So ratios are considered proportional if they have the same value, or they can be simplified the same into lowest terms. So when they have 2 to 3 is going to be the same as 6 to a value. If we reduce 6 to 3 into lowest terms, it'll be the same as 2 to 3. So that's important to remember as well. And I apologize about the grammatical error in this sentence. So ratios are considered proportional if they have the same expression when they are in lowest terms, would be a better response for this. So we're going to determine whether these ratios are proportional, and we're going to provide some support for our answer. So we want to think about, first of all, are these ratios in lowest terms? The first one is not, so we can put this into lowest terms by dividing both of our terms by 2. And when we divide both of our terms by 2, we get a ratio of 4 to 1. Now 4 to 1 is not the same as 5 to 1. So these ratios are not in proportion. So they're not proportional because these ratios in lowest terms are not going to be the same. So now we'll take a look at example B. So we have 8 over 12 and 6 over 9. So 8 over 12 can be simplified. We can divide both of these terms by 4 in this one. And when 8 divided by 4 is 2, and 12 divided by 4 is 3, so we have 2 over 3. Now we're going to take a look at the second fraction. So this fraction, both of these terms can be divided by 3, so both the numerator and the denominator. So 6 divided by 3 is 2, and 9 divided by 3 is 3, and those two are exactly the same, so these ratios are proportional because the ratios in lowest terms are exactly the same. And the last example that we're going to take a look at, we have 9 to 12. So we're going to start with this first ratio. Both of these terms can be divided by 3. So we'll start there. So 9 divided by 3 is 3. And 12 divided by 3 is 4. So that's good. So we have this in lowest terms. And now we're going to take a look at our second ratio, which is 21 to 28. And both of these numbers can be divided by 7. 21 divided by 7 is 3, and 28 divided by 7 is 4. These are equal, and so these ratios are proportional. So in order for ratios to be proportional, they have to equal the same ratio in lowest terms. So knowing that, how can we state 3 different proportions that are equivalent to 3 over 5? So this would be the same as writing equivalent fractions when we looked at this at the beginning of the school year, or beginning of the semester. So an equivalent fraction to 3 over 5, or equivalent ratio or proportion to 3 over 5, might be 6 to 10. So we're going to divide both of these terms by 2 to get 6 to 10. We may choose to multiply both of these by 10 to get 30 to 50. Or we might decide to multiply them by a random number like 8, and we might get 24 to 40. It doesn't matter what number you choose to multiply by, as long as you are multiplying both of those terms by the same number, then when we put these into lowest terms, they're going to be equivalent. So these are just 3 examples, 3 different proportions that you could have done, but you could have multiplied, like I said, by any number, any 3 numbers. It could have been 3, it could have been 100, it could have been 7. It doesn't matter as long as you're multiplying both terms in that ratio by the same value. So now that we know the concepts of equivalent fractions and we know how to determine if ratios are in proportion, we're going to use our skills of algebra. So when we looked at solving equations, so this is going to come in very handy for us in order to solve for proportions. So what we want to do is we want to isolate x. So we want to get x all by itself. And in order to do that, we have to move anything that's not an x to the other side. So we're going to start by moving over the 6. So right now it's being, the x is being divided by the 6, so the opposite of division is multiplication. So I'm going to have x is equal to 15 times 6, and I can either use my calculator or I can use my mental math skills, whichever is easier for you. No shame in one way or the other. So 15 times 6 is 90, and that is the value that makes this proportion true, or this statement true. So now that we have just reviewed sort of how to solve for an equation like this, we're going to look at it as if it was two fractions now, because that's what your proportions are going to look like. So when we're solving for proportions, we're going to have something that looks like this. So whether our unknown is at the top of our fraction or in the bottom, it makes no difference. We can use what we know about solving algebra to solve for those missing values. So I'm going to start by, again, moving over this value that's on the same side as the x. And as the first one, when it's on the bottom, so right now x is being divided by 24, so the opposite of division is multiplication. So I'm going to times by 24. So I'm going to have x is equal to 3 over 5 times 24. And when we're timesing, we go right across. So it's the 3 times the 24, and then over 5. So this is going to be, well, 3 times 24 is 72. So it'll be 72 over 5. And you can keep this as a fraction if it doesn't work out nicely, because we want to try to avoid decimal numbers in our proportions if possible. You could also write this as a fraction as well, or as a decimal number as well. So we can keep it as this fraction, and this fraction is in lowest terms, or if you really wanted to convert that into a decimal number, you just take your numerator, so your 72, and divide by your denominator, so 72 divided by 5, and you'll get 14.4. So either of these versions of the answer would be acceptable. So now we're going to solve for these proportions. So the first two examples, we'll notice that our missing value is at the top, so it's in the numerator. So we're going to follow a strategy that is very similar to what we had up there. So we want to start by taking our 8, and we're going to bring it over and multiply, because right now x is being divided by 8. The opposite of division is multiplication. So just like in the example just above there, we're going to have 8 times 42 over 56. So you'll notice I put it in a slightly different order than the one up there. It still means the exact same thing. So I'm taking my 8, I'm timesing it by my 42, and then I'm dividing by 56. So I can do this like this right here. If I wanted to, I could do it like this. Or if I wanted to simplify this fraction up here first, I could have done that as well. So this becomes 8 times 42 is 336. And I'm dividing by 56. So x is 6. So this is one way to do it. So the other method would be to simplify this fraction first. So I could simplify this fraction by I can divide both of these by 7. So that's important for us to know. So if I divide this, if I simplify this fraction, it would be 6 over 8. And then I can easily say, well, if the bottoms are the same, if my denominators are the same, well, then x will equal 6. So this is a way to do it algebraically, and this is another way if you were to simplify. So this is simplifying the fraction first. And so this method works if your fraction can be simplified, but as an example number 2, it doesn't work like that. So we have to use this method. So this is the algebra method. And this is if you could simplify that fraction first and your denominators happen to be the same, well then your numerators would be the same as well. So for this one, I'm going to have to do the method, the algebra method that I did in the first section of this example. So I'm going to take 17. So right now the n is being divided by 17. The opposite of division is multiplication. So I'm going to multiply 4 over 5 by 17. So n is equal to 17 times 4 over 5. So again, you'll notice I've written this all means the same thing. So that's why I'm showing it to you in different formats so that you understand that all of these things mean exactly the same. So you can write your 24 at the end and show that multiplication. You could write it in front and just on the numerator, it means the same thing. Or you could write it in front of your fraction, written like this. All of these mean the exact same thing. And it's important that you understand that and you can recognize that. So now I do a straight multiplication across. So I'm going to do 17 times 4, which is 68. And then I'm going to divide by 5. So this fraction is in lowest terms, or I could write this as a decimal number. So 68 divided by 5 is 13.6. So it's great when they're nice whole numbers, but sometimes they're not. Okay, so you can, again, like I said, you can keep it, your final answer as a fraction, and if it's in lowest terms, or you convert that to a decimal. And so the last two examples that we're going to work through, so you'll notice that our unknown value is on the right-hand side instead of the left-hand side, but we're still going to follow the same strategy as in the first two examples. So I'm going to still isolate my m in this case. So right now m is being divided by 8, so when I bring this over, I'm going to be multiplying, because the opposite of division is multiplication. So now I'm going to take 8 times 21 over 30, and that's going to be equal to m. So I'm going to multiply straight across again. So 8 times 21 is 168, and I'm dividing that by 30. So I can either express this into lowest terms, or I can write this as a decimal, and probably it's much easier for you guys to write this as a decimal. So 5.6 is equal to m. So 168 divided by 30 is 5.6. So you can definitely keep it as a decimal. All right, and one last example. So if your unknown happens to be at the denominator of your fraction, there's one of two ways that you can do this. So I'll show you the first way, and then I'll show you a second way. So this is method number 1 that I'm going to show you. And I'm going to show you method number 2 as well. Okay. So we want to isolate w all by itself. So some people will take the w, and we're going to move this over to the other side. So right now 12 is being divided by w, so the opposite of division is multiplication. So it's going to look like this. 12 is equal to 5w over 13. So I'm bringing this over. So I'm bringing at the top of my fraction. So now I want to, again, I still want to isolate the w, so I still have to move anything that's not the same over. So right now I'm dividing by 13, so I want to multiply. So I want to, again, get my W all by itself, but I have to do this in steps. So I'm going to have 12 times 13 is equal to 5W. And I can go ahead and multiply 12 by 13 right now to simplify that. So 156 is equal to 5W. And then the next step would be to take our 5. Right now it's being multiplied by the W, so we want to divide it when I bring it to the other side. So 156 divided by 5 is equal to W. And that gives me a value of 31.2. So that's method number 1. Method number 2 is just to flip these fractions to begin with. So method number 2, flip both fractions. And by flipping both of the fractions, then it becomes a question where I don't have to worry about doing some extra steps because if I flip them both, then my unknown is already going to be at the top of my fraction. So I could have W over 12 is equal to 13 over 5. So I'm flipping both of those fractions to get my unknown at the top. And then I can take my 12 and I can bring it over and multiply, because right now it's being W is being divided by 12, so the opposite of division is multiplication. So I have W is equal to 12 times 13 over 5. 12 times 13 is 156. I knew that from over here. And then I'm dividing that by 5. So W is equal to 31.2. So either method works. So if you wanted to do some extra steps, you can do it this way. If you want to keep your question like this, or if you wanted to flip both fractions, you could follow the steps in method number 2. If you have any questions about solving proportions, please put them in the appropriate discussion board posts or send me an email.